Okay, so when Samsung come up with this Galaxy Z folding phone, it targets the tech-savvy and consumer that are willing to pay more if they can gain efficiency and also better experience. Yeah, they are not the low end; they are actually the high end user. And what this customer wants is they want to have an all-in-one experience at the palm of their hands. They want to do work, they want to enjoy media, everything in one, and also fun, right? Media, they want to have one. But because the phone is so small, right, it has size limitation. How do you make the size bigger and you can put it back to a smaller size when you want to put them away? So how do we solve this size limitation? So Samsung's come up with this solution, a folding phone. So in a folding phone, you can have an expensive design. Expensive meaning you can extend the screen size, and you can put them away when you can fold it back if you don't want to use it. And you can also have a smartphone that has multiple display to display multiple apps in one go. In one simultaneous screen, you can have multiple apps. So with this, you can have a phone that you can fold, expand and reduce the size. And in the screen, the expanded screen, you can have multiple display. So this is the value that this Z phone is created. So in order to deliver this value, Samsung has to come up with some new solution, and they also patent the solution, and we're going to look at some of those patents today. So if you look at the Samsung's phone, it has evolved along from the traditional key phone, a Me Too key phone, to copy Apple, to coming up with the original Galaxy Z. So from our research shows that this foldable phone are protected by at least 5 key patents. So what are the key patents? Patent number 1, right, is how do you fold a phone and you can have a feature that can sustain repeated folding, and yet, right, the phone, the screen, the flexible screen, will not break by or leave behind a line after repeated folding. So for that, what Samsung has done is it come up with a system where the display is broken into 3 parts. A first part, a second part, and a third part in between, right? If you can follow my arrow, you have the first part, you have the second part, and a third part in between. This is a flexible screen. The first part is supported by a first body, the second part is supported by a second body. So when the first body and second body are clamped together, it will leave behind. If you can follow my arrow, you create a space here, a receiving space, right? A receiving space, so that the screen, the flexible display, will not fold sharply. It will become a curved portion. It become a curved portion and rest in this so-called receiving space, right? So when you fold and it rests like this, it wouldn't get creased easily and it wouldn't break, right? Because it's forever not closed sharply. It is always in a closed position. So when that happens, this thing will move, right? This the part A will move, and they put a stopper at the front to stop the screen from sliding out. So this is the solution introduced by Apple to come up with a folding phone, having a screen that fold but yet do not close sharply. And if you look at the patents, right, filed by Samsung, What is a pattern? Pattern is when you come up with a combination of parts and you claim that combination, and that combinations belong to you, and any competitors follow this combination, they will be infringing your patent. In a patent, you claim the combination to own the combination. So in this patent by Samsung, which was filed in 2017, right, and granted in 2014 and granted in 17, this patent, what is claimed is you have the first body, as I mentioned just now, and the second body, and the flexible display supported by the first and the second body, sliding in the rotation of the first body, and you have a movement limited member, which is marked as 331 to 6, 331 to 6. Yeah, these are the 331 to 6. These are the movement limiting members to prevent the screen from going out of the margin and fall out from the side. So this is what, it's a simple solution. You want to fold, you don't want the screen to get damaged. How do you do it? You maintain that screen at a folded stage, a curve, and rest it in between the two bodies. And you have the stopping member to stop them from going out. So this is the first pattern, to give you an idea of what Samsung has created. It's not a rocket science technology. It's just a clever manipulation of the curved screen and the flexible display, and also the bodies of the phone. And the second phone is, in order to have a foldable phone, you have to have a foldable display that can stand repeated folding, right? So you fold many times, you even though it's not sharply folded, it will create certain crease, right? So how do you come up with a display that can withstand repeated folding and also does not affect the electronics of the device? So this one has to improve the material. So what Samsung has done again is to have a display module having this display screen will have multiple layers, and the key layer will be a display module. This display module will be the module that shows a picture, but beside or adjacent to the display module, they put in other elasticity adjusting module layer. This elasticity adjusting module, as you can read from the claim, right? The claim, this combination of steps, combination of feature, it has multiple layer. You have the most important is the display module that display the picture, and adjacent to that display module, you have an elasticity adjusting module with a elastic modulus, which is less or equivalent to all the other module. So the other module, in other way, is having an elastic module which is lesser, meaning it is more flexible, and it will, when you fold the screen, all the other layer having lesser elastic module will take in the stress. So that display unit will not take any stress, so that you create a neutral plane within the display module. When you have a neutral plane, it means you have no stress at all. So if you don't have all this elasticity adjusting module, the neutral plane will not be inside the display module, right? It will be outside, and the display module will face stress and the module will be damaged. But by cleverly adding in an elasticity adjusting module, which have a equal or less elastic modulus than the display module, you can move the neutral plane within that display module, and the display module will suffer no stress, and therefore it don't get damaged even though you have repeatedly folding the display module. Okay, so this is how this combination helped Samsung to come up with a material that allows it to be folded multiple times without damage to the display module. right? So this is the second patent that make folding phone set a reality. The third pattern that I wish I like to share with you is, how do you increase the screen area, right, of your phone? Something that you can like extend and retract easily. So for that, Samsung come up with a mechanical system. This is not a rocket system. It is an old school mechanical system of joining, first a flexible display with a base housing. The base housing is the basic housing, the basic structure unit of the phone, and interplay it with a sliding housing and a folding housing. So flexible screen plus base housing plus sliding housing and a folding housing put all together, then you can have a structure that can fold, open, and you can extend to enlarge the screen area, right? This is what Samsung does in the Galaxy Z series. Okay, so this is how it works, right? You can see again the claim of this pattern is a combination of parts. Like you have the base housing, you have the sliding housing, partially overlapping with the base housing. You have the whole folding housing, partially overlap with the partially with the sliding housing, and you have a display, flexible display, which is disposed. Sorry, I'm looking for my arrow. Which is the display, which is disposed on the folding housing and the sliding housing, and located within the base housing. So when you do the sliding, right, the folding housing and the sliding housing will move to do the sliding, and when you do the folding, the folding housing will operate to do the folding. So it's a mechanical part, it's a mechanical configuration of having the four parts joined together. But if any of the competitors will want to use this combination of display plus basic housing plus sliding housing plus folding housing, they will be infringing the pattern of this Samsung's patent. Yeah, because they are the first to come up with sliding and folding in one smartphone, and no others have done that before, and it was patented by Samsung. The next is about screening. This has to do with the software portion of the phone already, especially when you when you fold the phone, right, at the folding zone, the foldable zone, the image, you will have discontinuity in the image, or you have blurring, right? Because when you fold your thing, you cannot see a continuous image. So in order to produce a continuous image, Samsung has come up with a software that can produce different display zone, right? When this different display zone will appear based on the folding angle of the display unit. So when you fold your phone to a certain angle, the display, the change of folding angle will be detected by the controller, and the controller will activate the other zone to appear on the screen, so that you can see different display and different apps appearing on the phone. Okay, so this is what this software is doing. So when you fold the phone, right? So when the angle detect that you are going big, then the controller will control the image to be displayed on a certain area in your screen. And when you fold, certain area will not appear. So this is how you can, if you can follow my screen, this is how it control. You have a control unit, you have an angle sensor, you have the storage unit to keep those content that you want to display, and you have the first screen and the second screen. So when the angle detect the folding, and the display unit will show the content based on the angle. So if you read the claim, this is what they claim, right? You have detection of the angle, controlling and display. So this is how you have multiple screen on multiple apps in one screen based on whether it's folded or it is open. And this is a software control, and this method is protected as a patent. Last but not the least, there's this another software patent that also helps the user when your phone is folded completely. You cannot operate on the phone, right? You cannot operate on the phone because there's no display area for you to operate the phone. So what they do is Samsung come up with two areas. First area, when you fold the phone, you don't fold the phone symmetrically already. You have two area, one area bigger than the second area. So there's a detector to see when it's folding. When you fold, the phone is folded, then the user interface will appear on the exposed area. So when you open up the phone, the entire app will appear on the screen. When you fold the phone, only the user interface will come on the exposed area. And this is all reflected in the patent claims, right? So as you read this claim, it comprises of a combination, and you have the flexible exposed area, and you have a detector and a controller that control the display. When it is folded, then you will display a user interface on the exposed area. And when it is unfolded, you will display an entire app on the screen, right? So these are some of the building blocks of this Galaxy Z, which is patented. And the design, of course, of the folding phone is also protected by industrial design, as you can see in the screen, and also the end device.